17, right?
Did you see the number that I put in? It's like on the bottom right corner.
I did not see it. I still don't see it.
The bottom right corner of this page.
Yeah,
of this. No?
I have nothing.
Okay, well, I put like 1809304 because I don't know the number. So.
Okay.
I just put a random one.
I just think it'd be interesting. We should probably start tracking that.
Yeah.
So
I noticed that I had 215s already, and then I was like, okay, this is already done.
Cool. All right, so let's just jump in. I want to quickly get you guys up to kind of give a quick overview of the new code refactor thing and go over that with you guys. So I think it's the most important thing at the moment. So I want to. It's kind of a blocker for you guys being able to contribute to not have that. So let me see if I can't share my screen.
Look.
Yes.
Can I propose something?
Please.
Let's try to come up with a cap for like an hour of this demo that you're gonna do, and then come up with like a 30-minute cap for us to discuss the domain architecture language.
Sounds good.
Because both of them are impediments, but depending on how much we dive in terms of depth, it might be a little less inefficient than if we just, you know what I'm talking about.
Okay, so let's aim for more like 30 to 45 minutes. So let's give a hard number. Let's do 40 minutes for this next demo, and hopefully it'll be less than that.
Okay.
And then we'll spend the rest talking about DACL.
Okay.
Okay, so 3:10 my time. That'll be our move along time. So, all right, cool. Let me go ahead and see if I can't share my screen without it working. Share screen.
I'm gonna get a Coke while you do that. Be right back.
Okay, it should be sharing. And if it borks on you guys or starts to flip flop, let me know. But it looks like y'all can see, right?
Yep.
Great. Compare and pull request. Not sure what that's supposed to do. Okay, so I have to learn about this whole pull request thing. Oh, branch, FFTMF, I don't want to be on there. I want to be on develop. Okay. So, Davi, you there? Davi, you there?
Okay, I'm back.
Okay, great. All right, I want to show you guys how this is going to work. So if you come over here to, I need to add you guys to as a BioWonks contributor. So I guess I can go ahead and do that. Although I think I'm signed in as the Goldrick. So I'll get you guys on contributors here, and you'll get an email invite, and you'll just accept it. So I will do that. Put this on my to-do list. So if you go to BioWonks, and this should be public information, BioWonks projects. There's actually a BioWonks. That's the user right now of GitHub that this is kind of contained under. And originally I had the MiST Eco and the MiST API kind of, and the Seek Depot API thing out there. But I've since moved to a so-called monorepo. I don't know if I can give you a good explanation, but here's a good link. I can send out some of these. A monorepo is basically this collection of all your projects under a single repository. So because this can contain, the MiST API, the MiST pipeline, Seek Depot, DACL, whatever we may want, I actually just ended up calling it projects as the umbrella group. So may not be the greatest name, but for now it seemed to read semantically nice, like BioWonks projects. And you pull down this, and you're going to get all the projects that we're working on. So if you dive into here, the key thing is, let me go to develop. So on the develop branch, most top-level folders will all correspond to actual projects that we're dealing with. So there's DACL, There's the MiST API, MiST lib, and MiST pipeline. Cruft is kind of, I actually probably will remove it. It's just kind of leftover code that is hanging around for reference purposes in case we want to reuse it. But it could be, it's just kind of, you can ignore that. Common is just, I kind of use the convention of underscore to kind of denote that it's special and not an actual project. But it contains some common utilities. But typically we'll have in this top level folder all our major projects. So and this, as you can see, I don't know if I broke it out a little bit. So originally the pipeline was actually a subfolder of API. Well, that kind of sort of made sense, but it sort of didn't, since it can kind of function in and of itself. And and secondly, when we deploy the API, it's just going to be serving requests up to the database. It doesn't need to have all the pipeline code buried in it as well. So I actually separated those out because you can run them independently of each other.
Makes sense.
And then MiST lib is kind of basically all that shared code that we want to use both in the API and the pipeline. But you could also imagine, we'll stick Seek Depot under here with its API and its whatever. We'll add a MiST-web probably for our front end website, and go forward with that. So
let me interrupt you. Which is the directory that is shared between two MiST lib?
MiST lib, yeah.
Is it in pipeline or API?
It will be reused. It's used by both of these.
Okay, got you.
So if you stick something here, it should be functionality that we want to use for both of them. And let me get this out of the way. Oh, bloody. I don't know if I can memorize it. There. So if you, and I'll show you how we I made that work in the actual code base. So you have to do a little bit of hackery, but not much. But does that kind of make sense so far?
Yes.
Yeah.
So what's really cool about this is that we can now, with one command, have all our entire projects at our fingertips. Off we run. And so code reuse, and suppose we change a function in the API that is also needs to be updated in our website, because it's going to know our front end website needs to use that new route that we've added to the API. Well, we can do both of those in one deployment step and so forth. So there's just a lot of advantages. You don't have to deal with versioning and so forth. Because previously, what we would have to do is if this was its own separate repository, we'd have to go make the change there, commit it, deploy it, and now in the meantime, our website is referring to a out of sync version of the MiST API. So we'd have to, tag it to that old version, and then go update the MiST website and to use the new API version, and you just have this juggling that kind of gets annoying, and so forth. So there's some. I'll send you all some links if you're interested on all the advantages, but I think it's going to prove to be useful. And so forth. So DACL, I've already made a folder in here because I think you guys had made this JSON file talking about stuff. And we can also stuff documents or whatever under that, but that could very much be its own project, and then we just reuse it however we need. So, but that's kind of the straight up how that works. Nothing too fancy. We obviously need to update our README, and I'll probably try to spend some time on that somewhere here. So I wanted to show you guys how this works in practice. So if we come over here and we clone it, let's do it in a temp folder. So I'd say git clone. All right. So I now have my project's repository with everything in here, and you can see that the directory structure is a little wonky because by default it pulls down master, and most of our work is in develop, so you got to check out the develop branch. And now if I reach, I show my stuff, it should match what we have over here.
Cool.
All straightforward here. So I'm going to jump over to VS Code. Can you all see this all right?
Yep.
Okay, so I'm going to go over to the one I just cloned. And here we are. Let me make this larger for you guys. So the way this works is that I'll start with MiST-lib. So MiST-lib is our library for shared, everything shared. So this is where the FOSTA sequence stuff is and so forth. All this stuff is familiar to you guys and so forth. If you to kind of compile it and test it, you simply go into this folder. And it's important to treat each of these top-level folders as a separate project still. It's just contained within one repository. So the key thing is that you'll have to do on each one of these is an npm install. And that does a lot of bootstrapping as well as installing the requisite packages as well. So nothing too new there, but if you look at the package.json file here, there's some special stuff in this one that's like where we're creating a symlink and so forth, and this does it. Actually, we have a script that does it in a cross-platform way as well, so hopefully the symlinks will work. You will need to be running as administrator on Windows though, otherwise that'll probably bork. But so npm install basically just obviously installs all the packages, and then we have all our other stuff that we're used to here. So npm test runs all our tests. So 614, everybody's happy. No problem there. npm coverage is set up now as well.
So are you in the container or not?
Oh yeah, good point. I have this is actually not. I have not ported over Docker yet, so I'm kind of showing you a hacky way. Docker, I just didn't have time to quite get it integrated yet. That's the next step here. So
that's why you are concerned about the priorities on Windows.
Yeah,
you wouldn't have that trouble if it was Dockerized already, right?
Correct. That should, yeah. That should.
Okay.
And there might be some cases where you want to run it local to your host system for debugging purposes or whatnot, but coverage, all that stuff is in there, and so forth. So I got our contributors in there. I need to actually put our email addresses. So nothing too hard there, right? It makes sense.
Yeah.
So, and again, think of anything you put in the MiST-lib folder as going to be injected and available to, at this point, MiST API and MiST pipeline. So I'll show you guys the pipeline and how that works. So let me close this guy. Again, package.json is kind of our key file, a go-to file here for each project. So now we're in the MiST pipeline project, and I'm in this package.json file. And you can see we have everything related to the pipeline here. So pre-install this. When you run npm install, it actually runs three things. It runs, if you have a script called pre-install, it will run that before running the install, and then it actually installs all the packages. That's not the second thing it does. And the third thing it does is it runs a post-install script if you have that configured. This is just all out-of-the-box npm functionality with your package.json file. So some of the hackery that we have to do with getting our dependencies set up is a pre-install script. So think about it. If you remember in MiST-lib, we have a bunch of files which have their own various dependencies. Well, the pipeline is basically one needs all those dependencies as well as some of its own. And so we gotta have a way of combining those, and so that's what this pre-install script does. Is it calls another? It does some helpful script stuff that actually merges all the MiST-lib dependencies and puts them in this package.json file for us automatically.
Cool.
Make sense, sort of?
Yeah. Yeah.
So
Yeah,
node module directory, is it in the
I missed that. Say that again.
node modules directory.
What it actually does is it takes the package.json from MiST-lib. It doesn't copy the node modules directory, if that's what you're asking. It takes the dependencies listed in this MiST-lib package.json and it injects them into the package.json of our pipeline or API, whichever.
I got it. What I didn't get is, does each of these directories have its own package.json file?
Yes, correct. Yeah,
So they will each have their node modules directory.
correct. So I'm going to just run npm install, and that'll put a that'll create a node modules directory and under MiST pipeline.
Okay, so it means that if a package is shared between two directories or whatever, it will be installed twice.
Yeah, twice in the sense that it's installed under MiST lib and once under MiST pipeline, or I guess MiST pipeline and MiST API. Sure, yeah.
Okay.
So anytime we deploy code or update code, we'll want to run an npm install, and that will make sure everything is good and running. So yeah, it's a little less efficient on disk space on your local file system, but that's a relatively small price.
One thing is, you think in the future when we package this to deploy as a master to release, we're gonna have a single npm install to install everything, or we're gonna actually make our users to go in each one of the projects and run npm install?
I guess it kind of depends on what's most useful. We certainly could do that. At a top level, we can put a package JSON right here and have it iterate through all the relevant projects, compiling and do everything for you.
Okay.
But you can imagine if you have 15 projects, maybe you don't want to build for all of them, right? So
I think a lot of people are gonna just do that. They don't care about the other ones. But nowadays, the space on disk and things like that are so not relevant. Yeah, they're just gonna run the easiest command and then see what happens. I do that.
Yeah, understandably. Well, so that's something we should consider. I think it's an easy thing to add in when we see the need for it. So yeah.
The one way for us to sell MiST on NextBlast is a single line to set up everything. Yeah, or two or three, but not more than that. We talk about how complex this is, and then I'm like, and we resolve all this for you. You hit this button, you get MiST on your computer.
Yeah, I like it.
Yeah.
I think so that would be certainly just building the API and the pipeline and so forth out the bat.
Right.
And they don't need to know any of the details of.
Yeah. For us, I think it's important. Then you can actually put in the manuals, like, hey, if you're an advanced user, here it is, how to actually do it properly, or not automatically, or customized for your own use.
Yeah.
But if you just don't care, if you just want to serve MiST locally so you can query the hell of it, just do this, and this is the computational requirements that you might need to do all the computations.
Yeah, that's a good idea. That's a great idea. So we'll definitely have that, work on making that streamlined for at least for the blast, and when we get there, or you guys could add it if you want as well. I mean, essentially, all that's going to be is a. Well, I'll do it later. It doesn't matter.
Also, now that I'm thinking, I'm gonna just throw out there, since we're recording, would be cool also to see, for example, if people don't want to do the entire computations that we already did, to let our scripts have some way for them to download our database locally. So, because since we're gonna have an open source and this is available online, might as well, for us, it's better that actually they run their queries locally in their computer than in ours.
This is against the point of API, right?
Right, but it's also not against. It's there. I don't know what is the problem that we might have, like downloading stuff
that you would get.
Huh?
What is the benefit that you would get?
Well, I could see some cases, like if you're a private company or you're working on unpublished data and you want to keep your genome private but have all the functionality of MiST, you might want to have a local version of it for those kind of purposes.
Or a large group, for example, like 20 people, like Eugene Kooning or Pierre Bork.
Or yeah, or you just want to have a private server because the actual MiST server is going too slow or something.
Exactly.
Uh,
Or if you want to actually build on top of MiST. If you think MiST is great, it's a nice infrastructure, but it's not enough for your purpose.
yeah, you could.
Fork this thing, put in there, and they don't want to do all the computation because they're already done. Download the database and leave us alone.
Yeah, because I mean, I guess the API is more piecewise eating the data, but if you want a huge data dump, it's not exactly the ideal mechanism for getting that.
For example, I will do that. I will clearly build a MiST inside of my computer and run the API on my server. Or run my SQL data. But like I'll try to use the API, but I'm gonna actually point it to my local data because I use a lot. So
Well,
just
so,
something like that.
but it's a good point, yeah, and yeah, all these things are easily doable. Now we got a good setup here, so
Yeah.
definitely. Okay, so I've run npm install, and I am ready to go to town with my pipeline. That's all it took was npm install, and it took care of automatically pulling in the MiST lib into my MiST pipeline. You're like, well, how did it do that? Well, there's actually, it's easier to show if I go there. So within each project, except for MiST lib, there's a source folder. So MiST pipeline has a source, and that's where all the source code goes. And MiST API, there's a source folder, and that's where all the code goes that is relevant. And so yeah, that's one little directory change to be aware of. I did that for a little better organization and also to streamline the handling of tests and so forth. But if you look under the node modules folder, so there's actually another node modules folder underneath source. And I'll explain this why we do this in a second. But under that node modules folder, we have a couple of symlinks. The first is a lib, which points to our own library function specific to this project, in this case, MiST pipeline. And then there's the MiST lib symlink, which points all the way up to this project itself. So now, using a symlink, we can get all of this code instantly into the pipeline. So if I edit a file here, it's automatically going to propagate those changes to MiST API or anything that's got this symlink in it. All straightforward, right?
Yep.
Okay, and so the way this happened is there is after we run npm install, there's a script called install symlinks. And so if we look at what that does, it's making a symlink, and source node modules, MiST lib, points to that. It's just basically running symlinks creating symlinks in a cross-platform way is all. But if you wanted to see how that's happening, it's the post-install script. Anyway, so now we have these accessible to our project very easily, and so just to make sure that what happened there, that flow makes sense, right?
Yeah.
Ogun?
Yeah.
Cool. So now here's a little bit of a hack that I did. Well, it's not even a hack really. It's like, why do we have a node modules folder up here and a node modules folder down here? Well, the reason is that the node modules that's directly underneath your project is all basically the third-party modules that this project needs. So, however, the node modules folder under here is just kind of ones that are local to this project. So the real advantage of this comes from when we start to require files. If your file is underneath the node modules folder, you note that you don't have to do a require and then spell out the full path to it or relative path to it. You can just basically treat this as a root. So to kind of demonstrate this, if I come into modules and I say, let me do lib, I guess, services. So like async compute service. So for instance, this one this class derives from async service, which is in the MiST library. Well, now because of the way I have MiST lib underneath my node modules folder, I can simply say require MiST lib services async service, and that immediately grabs it from this folder right here. Bam. So instead of the opposite way of doing it was I would have to do like ... lib blah 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 blah, right? So now I can just very easily, no matter where my source code is, reference it with this kind of root prefix, which is a lot more convenient. And so that's because, and that advantage comes to us because now we have the MiST lib directly under a node modules. So the way Node works is if you say require something and it doesn't begin with a ./, it will look for the first node modules folder that meets that criteria, and if that doesn't have it, it'll keep going up the tree and it'll look at this one and so forth. So that's why Bluebird, it's like, oh, it's not here, and it keeps going up one more. Oh, yep, it's right. Well, there it is, Bluebird, bam. So I want to make sure this makes sense to you guys before.
Yeah.
Kind of confusing to me still, but it's okay. Go ahead.
Okay, the takeaway is that you can now refer to any library outside of MiST lib, just by, or any library inside of MiST lib by just saying require MiST lib and then the path within that.
Yeah, I got it.
Okay, that's the takeaway there, and that's why we have two node modules folders to kind of get that functionality. Okay, so that's pretty much it. So I have a bin folder, and the bin folder is basically kind of those scripts that we use for running things, obviously. So like pipeline sh is in there, and that basically calls pipeline, install symlinks, and some other stuff. So that's just to be aware of that. So if we say pipeline. Okay, I don't have the pipeline in here, or in the npm package stuff. But if you come over to the bin directory and we say pipeline, here's your lovely pipeline script as you've seen it before. So you would run bin pipeline.sh to run it, and off you go. So again, this is a fresh clone, and I've just run npm install, and I can immediately do this, and off we go. So you can see how relatively easy that was. It wasn't one line. But it was 2 lines, so we're still under the 3 mark that Davi imposed on us, which is a good. I'm being slightly facetious, but it actually is a really good. That's a good rule, I think. So and of course we have all the goodies in here. So npm test will obviously test everything related to run npm, and we don't have. I haven't actually done the setup, and that's why it's complaining about coils and seg not running. So I guess there's my third command I need, is to kind of get the setup going here. Anyways, yep, and coverage and all that fun stuff is in here. So npm run coverage. Okay, and it died. You can see it's actually a little bit low, but that's all right. That's not what we're talking about right now.
Coverage is the testing, right?
Yes, the code cover shows you how much of your code has been tested.
Okay.
And so each of these projects will have a testing folder. When you run npm coverage, it's going to create this full report under testing coverage. And then in here you'll have that lovely report that you've seen before.
Oh, yeah, that's right.
The testing coverage. So, yeah.
Very cool.
Which is really cool. And so this is going to go into our continuous integration, and we'll see all this out in the public website at some point shortly here. So that's the coverage command, which is awesome. Yeah, full linting is all going and rolling there too. So just as for the sake of example, I'm going to go to the API and kind of repeat the same thing here. So I say npm install. This is going to set up everything I need for running my API. And you can see what it's doing before and after with those scripts. And now all I have to do is say npm start, and my API will be up and running. Bam. So now I'm listening on my local host at, and there it is, talking to me.
Very cool.
So, and that was from a fresh, this is from a fresh pull, like I'm in temp projects, right? This isn't something I've pre-configured beforehand. The only pre-configuration that is going on right now is Docker. I have the Docker running in the background, and that will have to be automated yet, but that should be tied in here seamlessly too. So, yeah.
Very cool.
And that's it. So, you guys, I'll get you guys on the contributor list, and you can pull it down and start going back hacking all the code again. Of course, it's going to be a little trickier without the Docker for the time being, but you can run a lot of it without the Docker, actually, since you guys are on Macs. Amit on Windows will have a little more troubles. But Mac and Linux, it's pretty fine, even as is. So that's pretty much it. Thoughts, feedback,
No,
comments?
this just makes sense. Yeah.
Awesomeness.
Cool. Maybe.
So I just have a question. So when you want to install a package, let's say you are in MiST pipeline.
And they missed what?
MiST pipeline.
All right.
So we are in the node modules. We are just creating another module, for example, and for that module we need to install a package.
Yeah.
So we just, from that directory, we just do npm install -s and the package name.
Yep. That'll be it. And it's good. So let's just do it. npm-s, I don't know, what's glob? And now glob is in our package. Where is this? Am I on the right one? Glob, there it is. See, that's telling us it's a new line. And
Okay.
it's it.
So it is in this package.json. Okay. All right. Where was the two node modules directory? Was it in MiST-lib?
It was in no, MiST-lib won't have one. It was in the MiST pipeline and the MiST API. See, API, node modules, and the source node modules, and then MiST pipeline, node modules, source node.
What I am confused is, when do we need to do? When do we need to?
When do
When
we
a
need?
module goes to this node module, but not the other one, I'm still not very
No
comfortable.
worries. So the most cases you'll never have to even think about it because it's going to be all like you just have to worry about npm install and everything else is completely taken care of. And for the most part, you'll never ever touch the source node modules folder. You should never even have to build it. If we were building out, it really only comes into play when you have library code that you're trying to make easier to access from the rest of your parts of your code. So if you follow, like, well, let's just work through an example real quick. This will make it easier. So I'm going to come in here. By the way, do you guys know how to create a folder down here very easily? Like if I hit new folder, okay, it lucked out that time. But say a lot of times I'll be clicking around, and then I hit new folder, and see how it's like sticking it way under MiST pipeline? Like I want to, in this view, create a folder down here.
Just click on.
I guess you just had to click there.
Yeah.
Okay, that was easy. All right, so let's see if that works. Hey, it does. All right, so Seek Depot API. Now we're creating a new project, and so let's just go ahead and make another folder called source, and then, for instance, suppose we want the MiST-lib in Seek Depot API. More likely be the other way around, but for whatever purposes, we could say new folder, node modules. And then let's, it's on my finger. We need a package JSON file. So let's just do npm init. Okay, so we got a package JSON
So
file.
you do that inside your source? Cool.
No, but it's not inside source.
Yeah. Oh, okay.
It's kind of confusing, but it's actually separate.
Okay. Can you
so,
do? Yeah. Your screen is blocking. I don't see where you are on your, because
Okay.
there's this Hangout is sharing whatever.
Oh, it's doing its weird stuff again. Or no, it's not.
No. It's just the sharing is on top of it. Can you hit hide?
Oh, this thing.
Yeah.
Hey!
Bam.
I never saw that hide before, and it's been driving me bonkers.
There we go. Now
Thank.
we're happy. Okay,
Oh,
I see now what happened. Okay.
I'm sorry, guys. I didn't think y'all could see that, and I thought it was just bothering me. Man, brilliant. Why didn't I? Okay, I feel stupid for missing that. So now, like under source, let's make a new folder called. Uh, well, no, we'll get there in a second. So suppose we want the MiST library in there. What I'd probably end up doing is just borrowing from this guy, install symlinks. So I'll copy MiST API bin, install symlinks. Dang it. Okay, so now I got my install symlinks in there, which is just, that's nothing more than a, well, you can see what it does. So for instance, I pretty much copy that all the way over. I don't even need to change any of that at all. So, and then I'd come up here in scripts and say post install okay, so, and this should actually go ahead and create most of my symlinks for me. So npm install. And so you can see the symlinks are already made, set up. So MistLib is now actually already automatically integrated in there. I think I'm doing a horrible job explaining this. It's the whole point of you create a node modules, a second node modules folder, and under that you just create symlinks to whichever projects you want or things you want to be integrated in there. So in this case, we wanted to borrow the MistLib, so we just made a symlink under the second node modules folder to the MistLib folder. What I was just showing you earlier just automated that, and so it was kind of fluff and distracting. I'm sorry for that, but that's technically all you had to do is just create that symlink, and you're ready to go. So now what I can do is in my new file I can say do awesome .js, and now I can say let seek equals require const rather MistLib bio seek, and I'm ready to roll.
Okay.
So that's, I feel like I did a horrible job explaining that. So ask questions on where I left gaps in the explanation.
Let me ask you another question. So, looks like all the projects are kind of dependent on each other, right?
To a degree. Like and right now we have yes, because lib is feeding both API and pipeline, and we don't have anything else at this point, but potentially not necessarily.
Okay, so MistLib is the common one that feeds others probably.
Like DACL probably won't have. This is probably just going to be more of a language specification rather than an implementation. It might have some implementation there, but it probably won't have a lot of what's in here. It'll probably be mostly unique. And so what we actually might end up doing is, wrapping that into its own project or something, or whatnot. It's too early to tell what's going to happen with DACL. So, I think we're all speculating in terms of how it's going to be implemented, and so it's hard to say exactly how that's going to morph into these other projects.
Okay.
But you can imagine CD-Vist being in here or whatever, and that might not use anything of these other libraries, right?
Right.
Yep.
So I was kind of thinking there.
All right.
Okay.
Cool. So this is kind of the first stab at this, so there's probably going to be some bumps in the way here. I mean, we could even make generator scripts that kind of help set up a new project so you don't have to do any of the thinking like I was just kind of hammering out by hand. So yeah, we'll probably run into a few snags, and just let me know, and we'll try to iterate on it and make it better and better. But yeah, that's pretty much the tutorial.
Very good.
Pretty straightforward, I think. Hopefully, sort of.
Yeah.
Sort of.
All right. Awesome. Well, I think that's it for me, and that's good timing because it's 39 minutes. So I guess I'll hand it over to you guys.
It's pretty good. All right. Ogun, you want to go first, or you want me to? Let me. I guess let me post this first, and then you join in. Is that okay?
Sure.
Because okay, so I'm gonna bring this back to me here. There's an increasing level of complexity that we can imagine when we're talking about backward. The easiest one that I think is what I do so far. So it's basically presence and absence of PFN domain models. You have to have this, and you cannot have that, and then you go and search those, and that's it. Now there's an increasing level of complexity, for example, ordering and everything else, up to what I'm going to show you guys now. This is probably the most complex version of it that I could think of. Or probably like there are instances that I haven't actually looked at, but I think you guys are going to agree with me that this is pretty close to the most complex version of it.
I am looking forward to it.
Okay. So this is my this is a snapshot from my notebook. Okay. Do you see my mouse here? You do.
Yeah.
Awesome. Look at that. Okay, so this would be our query, and each one of these numbers is a feature. And then you can start by classifying features. No, sorry. Each one of these is a type of query that should be able to merge or not. So let's go, and I divide them in two classes: ordered and unordered. Let's start with the ordered one. So first, you should be able to actually tell which one is your very first. Oh, and this is the other thing. I propose a change in name already, because it's not domain architecture at all times, but since one of the ideas is to use everything that has been, this is again, this is the most complex level, right? One of the ideas to use every single tool, every single result for every tool in SecDepo to define your protein family or your data set and your proteins you want to grab it. So okay, so you start, and then I propose the name to be.
Oh, okay. Yeah, I thought you were skipping over the name. Yeah, go for it.
PFQL, like Protein Feature Query Language, because now we're looking at features of the protein rather than just protein domains. I'm not sure if you can call the transmembrane a domain.
No.
Yeah, so that's what I'm talking about. Okay.
Yeah, that makes actually a lot of sense. I was wondering if it should just be FQL.
Yeah. Well, I thought about FQL too.
Well, let's decide it right now. We're in the middle of it. Let's just decide what we want. Make decisions now as opposed to postponing them.
Yeah. So the reason why I didn't go for FQL is because it's specific for proteins, right? But it doesn't need to. It can be anything else that has many features.
Yeah.
But it's for proteins, as we are thinking about.
PFQL. Okay. Well, I kind of like the simpler. If we're the owners of FQL, it's easier to. I feel like going from PFQL to FQL is going to be a harder transition in the future than FQL to PFQL.
Okay.
I don't know.
I'm in on the FQL.
Ogun, you got any opinion?
I'm not sure how we would be interested in other things than proteins.
I don't either. But I mean, if you could, and so it's not that if we go with FQL that it's going to be anything other than proteins. It's just that's kind of can be assumed, and it's one less letter people have to imagine or study in terms of acronyms. Um, and it's just assumed that it's all for proteins. But
The only PFQL is okay, but the only concern is it's very similar to PFEM. So it starts with PF. It's like PFEM querying language or so.
It's true. Speaking of that, I actually thought it when you said PFQL, I was like, oh, protein family query language. So,
like protein family. So we might need to find something instead of feature.
Unless you just do FQL. But then, yeah. FQL works, right?
FQL works for me.
Let's just run with FQL until we have a better idea. Okay.
Okay. So now let's go for like all the possible shenanigans you can possibly want to do. I don't know. I try to be very open-minded, but I think obviously any combination of this is predicted to be available. So there's a bunch of and ors that we can basically nest on each one of these features. I think this is just probably, there's some dependencies here. Well, we'll see. Okay. So the first one, you should be able to say, I want this feature, my prototype to start with a certain feature. This one. And then the obvious, in ordered fashion, I want a presence of a certain feature from any tool. So I should be able to say, I want a transmembrane from DAS. Or you can say, I don't want a transmembrane, actually you want a transmembrane for phobias.
Let me interrupt you right away. What is 0?
0 is starting with a feature.
What does it mean?
You should be able to tell them, I don't want anything. It's going to make sense soon. Okay. But like, for example, I don't want anything before this feature. This feature has to be the first one.
Example?
Transmembrane region, for example. I wanted this. The problem is when you mix unordered and ordered features. You'll see at the end. Like okay, I can give you the example right now. So even the way I'm thinking about ordered and unordered can be like this. I want a domain A, B, and C ordered in my protein, but I want also a presence of domain D unordered. So it doesn't matter if it's on the beginning or at the end. But I should be able to specify that actually I want my A, B, and C to be in the beginning, and then 2 other unordered domains at the end. It's just a specification that they're like, you should be able to tell them which domain should start your sequence, which domain shouldn't.
Anyway, go ahead.
Okay. Then the presence of the feature of any tool. Yep. Then this is another one. The 2 here is a minimum and maximum distance in amino acids between 2 features. Yep. So I want, for example, I don't want to bother that PFEM doesn't pick it up all the domains between my transmembrane regions, but I know if there's more than 50 base pairs and less than, let's say, 300, I will have the domains that I want. So I should be able to say, I want my sequence to start in a transmembrane region, have between 50 and 300 base pairs, and come up with another transmembrane region.
Hey, let me interrupt you also for a thought here. Does this speak to the presence or absence of a detected domain in this space, or does it have to be empty, or can it be in all the above?
Exactly. So there will be ways to define these constraints. Right now, it's just, it doesn't matter if there is a domain there or not.
Okay. Yeah, gotcha.
Okay. So the third one here is the presence of a feature defining many, there's a name here, many tools. For example, I wanted the the number 3 there, the domain number 3, I want it to be either the key for, I don't know, HTTPA's domain from PFM or the EggFM key, or, you know, like you can define the same, or a cog that is related to the histidine kinase, but you can actually have multiple definitions that will fit in that constraint over there from multiple databases. Then number 4 is that actually I wanted something to be there, but doesn't matter what it is, but has to have one of the domains in these databases. And the 5th should be, for example, I want it to be...
Wait.
Okay.
Explain the difference between 3 and 4.
So 3 is the presence, and then you define which one of the domains in each one of the databases are possible to go to 3.
So you just have a well-defined set of what you want there.
Yes. On the 4th, you just want something in there from a set of databases. Doesn't matter what it is.
Okay.
Chemoreceptors are great for this because, for example, I can select, I can basically pick it up all the possible definitions on chemoreceptors here. For example, I wanted number 4 to be either hemp or, actually no, I want a number 4 to be anything, but I want a number 3 to be either hemp from the PFM30, or I want to be a pass domain, or I want to be any of the pass domains possible. All these things can be possible there. Okay, let's go to 5th. It's a specific mandatory absence of that domain in that place. So I want everything that does not have the domain blah that I'm setting up in this position. Okay. And the 6th one is like the ability of you to end with a feature.
Okay.
Now, the unordered version is like, despite all these constraints, you can also, you can imagine between the 5th definition, the 6th, you have like a really long link. It doesn't need to be very short. So it might actually have many other things in there or not that you're not specifying, then your query is still getting it. So that comes the unordered part of this. You can put ordered definitions to be searched within your ordered, in an unordered fashion in your ordered definition before. For example, this number 7 here, let's suppose that this is A and B, and I want something like this, that looks like this, all these defined features, but also that will have 7. So 7, this 2 domains here, can be either here, or between these 2, or between this, or between that, or between these 2, but not in the beginning, because we said this should start with a certain feature. And the same thing with another is the absence of a certain definition. So I want that these domains here can be 1 or can be many, or can be another definition like this, but I wanted this to be not anywhere of this definition that I had before. You see what I'm saying?
Mm-hmm. Yeah. So
I think this is the most complicated possible way of querying a domain feature. And then you can see that now you nested these things, right? Because of the ordered and unordered version.
So yeah, it's like in a sense, a tree, or sort of each constraint consists of one or more ordered parameters, and or any more constraints. So a constraint can consist of a child constraints. And then to basically do an unordered query, you just have multiple constraints that exist independently, and that's by definition an or. Well, or an or not, or and, or whatever.
Yeah. Well, I don't know. There will be a lot of and ors, but I think in this way, there's 2 different, very separate way of searching this. The order version should be the first one that you get it, because the most constraints that you have. So you go there and search for the order ones. and then you do a post uh, uh, filtering with the unordered definitions from the ordered versions that you already got.
How do you? I guess we also need to have some sense of overlap, right? So, like, take number 3. I want a presence of feature. Like, do they have to be overlapping for number 3, or can it just be? I have a like, for instance, the way you've drawn it, it looks like you have another implicit constraint that all the features in 3 have to be between these two positions.
Yeah, well,
Or
exactly. So it has to be between this guy and that guy, like this transmembrane region and the fourth any domain, but the number 3 can only be one of these 3 options.
So, and is that like what if they're 10% overlapping or 80% overlapping, or like how do we define that?
Overlapping between domains?
Well, no, like at least the way you got drawn there, it looks like there's 3 boxes that completely overlap. Those are 3 tools that have predicted that, or I guess it could be 3 separate predictions.
It's an OR. This one is an OR. It's like either of those that matches, you go for it.
Yeah. So what I'm saying is, what's an OR? I mean, what if it overlaps by one amino acid?
It doesn't matter, like, because it's gonna have like you can have. Let's suppose that you have 3 different domains that will predict QW in 3 different databases. Those are 3 QWs, and even if they don't overlap, if one of them is like over here, the other one is over there, the other one is over here, it doesn't matter. Like either of those would fit. So it's
implicitly constrained between the left transmembrane region right to that and whatever 4 is, however that's defined.
Yeah, exactly. And the idea here is like you pass this information back to the user, but the user is using this just to define the protein. They're probably going to just pick one tool at the very end and actually tell what is inside. This is not for I'm not looking for display. This is how I'm going to define my query. I understand.
I got that.
Okay.
I'm just thinking, so like, let's keep running with your example. Like number 4, it's the absence of something. Would that have to be defined by a certain amount of amino acids? Because like otherwise, where does 3 know where to search within the sequence length, right? I mean, if 4 is 10 amino acids versus 300 amino acids, that's a big difference, right?
Let me think about this for a second. So 4 is the presence of any feature. Is it basically like the 5th one is the absence of something there?
Well, so even so, okay,
but
so
you have to. But you see, yeah, I see what you're saying. You're gonna have a problem because when you use multiple tools, they will overlap.
Yeah, the overlap.
They might change the order of who is the first one, who is the second.
Yeah, exactly. So I guess what would be nice to do, and this is maybe towards kind of what you were hinting at in previous conversations, is to have a unified domain architecture to query against rather than having to guess like this. Now that may be too much of a simplification, but like for instance, if we could say, we're pretty sure this is a domain in this space. And so everything that overlaps with it is now kind of tagged as a domain, even if it's for multiple tools. Well, let me back up. So what we have, I'm trying to map out the dimensions here. We have obviously the physical dimensions of the actual sequence length, so some kind of linear axis there. Then you have a variety of tools, which can be mapped to particular classes of tools. For example, a domain tool, you have PFAM, TigerFAM, AGFAM, or whatever, but all of those are domains at the end of the day. You have another example would be transmembrane. What?
TigerFAM is not a domain database. It's a protein HMM database.
Is that what?
It's a protein HMM database, not a domain database, TigerFAM.
Right. So we can call feature. Let's talk about features.
So, I mean, they are not interchangeable. So, for example, TigerFAM doesn't target domains. It targets protein families.
Okay, so yeah.
Right.
Smart or PFAM or I gotcha. But good clarification there. I got you. Or transmembrane regions for the class of tool, and
No,
you
but
got
hold on.
TMM, HMM, or whatever, right? So it might be nice and probably more user-friendly at the end of the day to take a more opinionated approach, because most of our folks probably will be willing to sacrifice some precision and just say, I want a transmembrane region here. I don't care what tool it's predicted with. And, you know, so I guess what I'm really driving at is to look at all the dimensions, and then, you know, kind of, it's really hierarchical in that respect. And at which level do we really want to drive down to the absolute deepest?
I think I do. I think we should. So I don't like that approach, because it really depends on how you prioritize things, how you define your unified domain architecture. I don't want that. So I should be able to look for a specific feature that is defined by a paper which is established well. And this, we shouldn't be after that, because it's not our job, and our definition of unified domain architectures may not be relevant to people. So what's relevant to people is, if they are interested in a transmembrane region, they can do, okay, I want a transmembrane region in between this amino acid and that amino acid, either predicted by TMHMM or DAS or whatever. So you can just put or statements between your rules, and if it is correct, if any of these tools predict a transmembrane region over there, then it is true. And it's very simple to do that.
Yeah.
Right?
Yeah, I'm with Ogun on that. I don't know if Ogun is agreeing with me or not, but like I that particular part, I agree with him.
So.
But now the point that I want to point it out is, I understand that we should go. I think this exemplifies probably how complicated this can get, right? I mean, we talk about several possibilities here. But we need also to think about what is feasible, right? And what is going to be useful. So I think we should tune the complexity of the first version of FQL for FQL. Yeah. What's the acronym for that?
FQL.
Okay.
Query language.
Okay. It's a FQ, whatever. Okay. So we should tune the complexity based on what we're going to deliver for the first version. And maybe we can implement more complicated possibilities for searching later on.
Yeah, I agree. Baby steps.
But but we need to have in mind that we want to have something that can be scalable in that direction. So
well, I think, but even more pertinent than that is, I know you guys have longer range vision of, you know, how to use this for other DVS means, but the most pertinent need right now is to, given the signal translation definitions that Igor hands down, get those implemented, and our query language has to support those at a minimum. So that's our number one use case, as I see it at this point, and then of course we can branch out from that. And so, I mean, do you guys agree?
I do. So yeah, I certainly do. And if you go to the DAQF folder in your develop branch of projects, so you'll see that JSON file, right? Mm-hmm. Can you pull that up?
I can. I'd have to steal a screen from Davi, but Davi, maybe you should go to it since you're.
I'll send you. Oh.
Actually, it's in the GitHub, right?
It is on GitHub. I am pulling it up now. There we go.
Okay. So if you see there, so there's a name of your query. So this is a single query. Actually, anyway. So the first thing, which I suppose Davi meant by 0, it is the first filtering, because you don't want to search all of these. You need to index some of these, not to search millions of sequences. And I'm just envisioning it as like indexing all the AC IDs by domains, for example. We may be able to do that or not. Anyway, that's why
yeah, that gets complicated when you go for other features. So you're gonna index like every single thing for the presence and absence of transmembrane regions and how many.
No, you don't do that. You just index. So this is how I envision things. If it is domain architecture querying language, there should be at least one domain that you're interested in. And it should be your starting point.
Well, but if you're gonna go for a feature one, can be just like I want everything that has a transmembrane region.
Yeah, I mean, I'm still not following what you're getting at, Ogun. I mean, like a domain or a feature, those seem kind of somewhat interchangeable, at least with the more generic proposal that Davi is.
I'm also keeping in mind that maybe I should not, but the feasibility of this issue. So this has, so you shouldn't be searching all transmembrane proteins at once. I mean, you shouldn't start from there, right? You should anyway. If you let's say that you're interested in domains first of all, not transmembrane. We'll talk about it later. And then this is our first filtering. So we are looking at KW domain. And don't pay attention of any of the meaning of these rules. But what I envision is, even if, for example, your rule 4 and 5, it's basically the number of domains in your protein and the order of them. For example, in that case, if you want something between number 3 and 6 domains, what you have to do is, okay, the index of your 3 and 6, the difference between them should be at least 1, right? And they're all queryable, and we shouldn't, the ordered one, I understand how Davi approaches, but the ordered one is very specific, and we should not go with that. It is very constrained.
No, I like this idea. So what we can do, and then I think I agree with Ogun on this. So what we can do, we can look at the query definition. Okay, so what we can do, we can have as soon as we receive the query definition from our user, we can parse this thing and actually get like, oh, all these domains should be in there. And now you select, you do a first filtering that is indexed in all the ASECs that have this information.
So yeah.
They have the mandatory presence of all these domains. And now we do a further down about the ordering or unordering parts of it.
Guys, I think we're still diving into implementation, and I think that's a secondary thing we need to be thinking about, because it's early optimization, right? The most important thing we got to do, I guess the most important question is, what's the minimal set of rules, as what Davi outlined here, that are necessary to capture all the signal transduction effects that Igor's defined. I mean, we want the smallest set of those possible, and moving forward with that. The implementation, we can think of ways to make it rock and roll. That's not a problem.
Look, this is too easy.
May I tell you what is the priority? The priority is to define the presence and absences, and the second priority is which is at the end terminal relative to the another domain.
Yeah.
And these are the priorities for now.
Yeah, I agree. It's basically like what Aquarium does really well.
So that's really darn easy then.
Yes, it's too easy. That's what I'm saying. I mean.
So
right.
So let's get a representation that captures those two things. In terms of a grammar, not of what we're going to put into the computer. I mean, that can be part of it. When I mean put on the computer, I mean what we actually send to the database. But
to be honest, this is ready. Ogun already did this for Aquarium.
I think it's pretty close. Yeah, you can just basically search if it's there or not, and then the distance, of course. Yeah. Because of its location, we got its location in there and all that jazz.
Everything. Igor is going to define this pretty much as MiST was defined before. The chemotaxis part is going to be really, really similar to what we had before. I'm going to be the one actually putting one or two constraints here and there. But like, for example, we have like multiple KWs that are being classified as KWs, and now we know that they're probably not just KWs.
Okay, so Davi, let's do the same thing that Igor's doing, but for you. So you want to take it a little bit more in depth. Go ahead and build out the rules as you see it.
But I can do everything with Ogun's query language.
So we got a query language. So FQL is done.
Yes. Basically, like for this, yeah, FQL is basically Ogun's already ported this. We just need to port it for JavaScript.
Okay, so here's what I want you to do. I want you guys to formalize this in the sense of, say, we're defining documentation or something to that effect. So you have a search box on our web browser, and you're gonna have to put stuff in there. Maybe Yogan's already done this with Aquarium.
It's already there.
So if it's just that, then we're done. Is that what I'm hearing?
Yeah. Well, so the point is, because we want to consider all these other ideas, it might be that we need a slightly different implementation than what Ogun did for Aquarium if you want to actually do everything else afterwards. So basically, what we're trying to discuss here is, can we use the implementation that Aquarium already have, or that will be locking us in a local minima that is a solution for what it is right now, but once we decide to actually do a FQL that makes sense, that is more like broad, then we're gonna have to start from scratch again. So I don't want to start from scratch. So I want to build the same thing that Ogun did, but with the possibilities for scaling up in complexity.
Well, so
that's why the discussion is happening.
I see. I got what you're saying. Well, since it seems fairly straightforward to already do the things we need, and we already have an implementation to reference with, I would say, given the immediate priority is just to get MiST live ASAP. Especially, January will be here before we know it. And so I don't imagine that we'll dig ourselves too much in a hole by going ahead and implementing it as is. We can, if nothing else, it just gives us more context to build out version 2 or go a little deeper with. And I honestly, as I see it now, don't perceive that we're going to be having to rework, and we're going to be doubling our efforts too much here. If we want to go deeper and we have a use case already for that, I'd say then that's worth thinking through.
And it's a separate project actually. It is a very big project. So I totally agree. Let's push this out with the basic stuff, and this is something that we can always put on later. And I believe it deserves a different directory under projects as well. So
I think it's a phenomenal idea. And I know people would die and crave for this kind of.
I think I was thinking about like why people doesn't do that already. No. And I think I got the answer. It's really damn hard to actually make something that makes sense, like that we're trying to think about. Especially with like multiple databases, and people don't have SecDepot. That's the main aspect. So if you want to define your things based on PFM database, you're blocked in with PFM, and it's hard to actually have all these tools computed in a single database as SecDepot is.
Yeah.
And this is what we need to learn how to take advantage of. I mean, this is gonna have, once we decide to push FQL out, we're gonna have to write a paper just to explain how this works and how good it is.
Definitely. Oh, absolutely. And then we can cherry pick some amazing examples too, which there should be plenty. I mean, this is basically getting yourself a speedboat for zipping to wherever you want in the genomic landscape or proteomic landscape. Yeah. So definitely. So don't take my comments as kind of this is unimportant. It's totally super awesome, and I've heard this request for a lot of people for a long time. Like, well, how can I do this in MiST? I really want to do this, but let's keep our focus for the time being on just getting MiST live, and then iterating on that. And so but this is obviously a lot of thought leadership here, which is we'll want to hang on to and not lose. So.
Okay, so how we're gonna do this? Ogun is more familiar with the code, but like I think he's actually a more advanced stage to do stuff in MiST that can be useful to do other things than this. I can tackle this and port his code from Aquarium, or maybe even write a similar one from scratch, but based on his language anyways. And
so what I'm suggesting is we shouldn't. Are we going to let this available, this search box, to the public, or we'll just use it for our protein definitions for the first release of MiST?
Well, let's just have it for um, our own consumption right now. It's for our tool on the back end.
Okay, so then it's very simple, right? It's uh, it's very simple to query the proteins, and we don't need. I don't believe that we need a different table in the database. We can just screen them all for after our all rules are ready, right? Do you agree or not?
I think so. Yeah. So what will
Oh, I see. So you want to just yeah. Since we're gonna do this only once, we just can actually make a table of like hemotaxis, signal transduction stuff instead of actually indexing domains.
Sure.
Make sense, Luke?
I'm trying to.
So instead of like using FQL with its own table, we can do a FQL that's probably gonna take a little longer.
Well, so we'll create a table called signal genes or signal ASICs, whatever we want to call it. I think it'll probably need to be signal ASICs probably works because it's purely dependent on the information in ASICs. And so what we can do is after each genome is processed, we just scan the ASICs that haven't already been scanned and slap it. I mean, it can really, in the sense. Well, no, I was going to say it could be another column in ASICs table, but I think we actually just want a separate table because we're going to probably want to annotate additional information on top of it. So yeah, just signal ASICs and then just grab
then we work the details of the FQL later on, but because we will need an extra table to FQL become generic, but we're not going to offer FQL for the public then.
Well, so see, FQL is just a language that you're speaking. It's not necessarily something that's tied to a specific implementation, right?
No,
so
it is in one way. For example, I can do all this as it is right now on SecDepot. It just takes forever, but it works. It works. My software does that all the time. And not all these details that we mentioned, but it does. I'm about to implement ordering too, which is not that hard. So then you can pass a ginormous, even for actually, even in Mongo implementation, you can press a ginormous query. It takes forever to actually run, but it eventually spits out everything you want.
And that's FQL, right? I mean, it's not.
Yeah, but like if you're gonna, we may want to put like a table, so FQL would query that table instead of querying SecDepot.
So yeah, but that's implementation specific still. That has nothing to do with your actual
expression
of the conditions.
Okay.
That's all I'm saying is like it's I guess to me it's like
Okay, I got it. I think the idea is we're gonna offer FQL, but it's not optimized for doing that because we're carrying SecDepot in the really strange way. But in the future, we're gonna actually work it out a table to do an intermediate step, and then we're gonna be faster. But the queries are already there.
But it's the same concept, right? Somebody else could look at FQL and make a better implementation in doing some other table structure or whatever, right?
Right.
It's FQL is not the implementation. It's how you express things and get results, and the implementation can vary. That's all I was trying to get at, and I think you got that. So.
Okay. Okay, good. You're good with this?
Yeah.
All right, so I think as far as next steps, I think we have a good idea of it. Let's I don't know, maybe Ogun you already have it, but let's get a formal definition of the list of signaling stuff that Igor already currently has. Formalize that into like a JSON file or something that we can consume with a machine, and then we need to write a little library that translates that into basically database queries. And then we'll build out a module for that. So you guys, I mean, I think there's enough work there that probably you both guys could work on it simultaneously. What do you think? Or do you want?
So this is what my gut feeling is. I know how to work on this project. I don't know how to do other implementations in MiST. I think Ogun is better off. He's better than me right now in coding things for MiST generic, so he can help you better. My intuition is, even though he would be faster to do this one, but he will be even faster in relative terms than me doing anything else.
Okay, so why don't you do? Here's a good way that we could break it up. Ogun can one of you guys. Ogun could be the developer, and Davi, you can be the test builder. So this is how a lot of times they do it in actual industry. They'll have dedicated test engineers or QA folks who they build out tests, and then the developer, basically does the implementation, and those got to be in sync or whatnot. So that's one possibility we can use for it. What do you think about that?
It's good. Davi should be only tester, but also the main guy defining the domains, actually, because proteins. Because we are not only talking about signal transduction proteins, but also chemotaxis classes, right? So right. This is something that we want to.
But chemotaxis, yeah.
So Davi should think about how to classify KAs and MCP signals.
Yeah, but that would be that's a second order thing. So the way any classification of these things goes, you first select the proteins, which the FQL will do, and then you run the classification scheme for chemotaxis.
But we need, okay, I got it.
Yeah.
But we need some.
But I can take care of the pipeline. Oh, look.
Yeah.
So look, do you think is a? Yeah, I like this idea of breaking down, but don't you think that we have other things on MiST that Ogun can help, so I can take over this and keep working, even though I'm going to be a little slower on the development side? Overall, it's going to be better for MiST.
Well, so I guess the question is, what is MiST lacking right now?
Yeah.
And so we got a little bit more of infrastructure, not much. We're getting there. We're really close. I'm talking about our server and getting live data in there. Our API needs a little bit more building out. So I guess, in terms of things that the API needs, we need to have basically this kind of searching stuff in there, probably to some degree. And then the website on the front end. So, and the infrastructure for that. So as far as the core data, though, we're really getting close to having everything we need for MiST. It's just this last bit, really, that we're missing. So, I mean, yeah, we can start branching off into the main website at some point here.
Yeah, and then the other question is, we mentioned this before, but like, do we want to bring like somebody else to help us with the front end, or are we gonna trust our instinct on design?
Well, as far as I'm concerned, unless somebody's doing it for free, it's us.
Okay.
Because I don't know of another alternative. And
how much you think it would cost?
Well, at least a good designer, $50 an hour, and however many hours. But for the designer to really be effective, we have to have a pretty well-defined vision ourselves of what we want.
Right.
And so, in some ways, we're ready for that step at this point, and we know best.
Yeah, no, you're right. We can bring a designer later on just to actually spend like 3 hours just looking at it and help us out as a consultant.
Yeah.
Just make things make sense. Yeah, I agree.
I know a developer. I mean, a UI guy, and I worked with him a bunch, and he'd be willing to help us out. But I think our value would be a lot greater if we have something in hand.
Okay.
Prototyping it already. I mean, we can find it with MiST, the old MiST database, but so that's another thing, I guess, as far as thinking out. There's a lot of, I guess, it's more artsy, but the notion of what should be on the website and what should be the bare functions there, right? MiST 2 just had a bunch of stuff in there, but it's by no means necessarily the right way or the best way. So that's not coding work, but it's definitely thought work that needs to be figured out.
Yeah, I have a lot of opinions about that.
I'm sure you do. So let me say something about it. Based on my conversation with Igor. So he has some ideas as well. Basically, there's two-dimensional metrics now, right? Which is sorting the signal transduction proteins by function. And what was the other one?
No, just by function. The other one is the one that we had before, if it like by complexity.
Well,
so we had by complexity. That's why you classify them like signal transduction one component, two component, and chemotaxis.
Right.
Igor thinks that this is not worth it, so then he goes and go for a function because he knows how to classify them by function.
Okay, by function and by system. So system is one component, two component. Chemotaxis.
Yeah, that's the complexity one.
Okay. Is it called what? Why is it complexity?
He called it this name. I'm not.
Let's call it system.
Makes sense.
Well,
No.
it makes sense because one component is similar is simpler than two components, which is simpler than chemotaxis.
Multiple proteins, sure.
Okay,
whatever. We can run with that for now.
So, okay, complexity and function. So we have a table, and some proteins belonging to one component system and belonging to transcription factor, and others are belonging to. So each cell in this table will have something, more or less, right?
Right.
Yeah.
So he wants that kind of information out for each genome.
Right.
So
heat maps.
we can simply put a table, of course, but however, what we can also do is there's D3 cross filter library.
Right.
So it is very useful for that if we can do that, and I remember doing that for other things, and it will be very cool visual to filter them out based on what you want. So you want only transcription factors, or you want transcription factors and one component transcription factors.
You can also just put a heat map.
Yeah, but that's, I mean, how you want something that you can navigate easily, and heat maps are kind of tricky to kind of drill into, right?
No, I mean, depends how many functions Igor is gonna have.
Heat maps wouldn't look good because for transcription factors you have 100, and for KW you have 1, right? So on the same table it wouldn't look good. Anyway, we should talk about it. But these kind of ideas, I'm sure each of us has.
Yeah, I'm saying the heat map was the first thing that came to my mind. I'm pretty sure you spend more time thinking about this, and I trust you on that.
So these are all valuable. Yeah, so this needs to be thought out and documented, and if it's figured out, it's one less thing the developer has to do on the fly. So and since you guys are pretty opinionated, I think it's worth thinking it out and writing it down. Then I can even just implement it, and I don't have to think as much. The one thing I do want, well, that's more of an implementation detail, but I guess it's somewhat relevant, is I want the website to be responsive. So this should work on a mobile phone. And so we have to think within kind of
D3 does.
What?
D3.js, what Gun was talking about, it is responsive.
So that's just one aspect. But yeah, I mean, you take it to the next level where you have, say, multiple graphs, that needs to be responsive, and those kind of things. Yeah. So because I know D3 can scale and to whatever your size is, but we don't want to lose function because it's just smaller, even though it's scaled. Anyway, that's just all I'm saying. Is just we need to keep responsiveness in the back of our head when we're thinking of visuals or whatnot. So
making responsive is a challenge.
What?
Making responsive is a challenge.
It is a crazy challenge, but I think it'll be highly important too. I mean, it's just everybody's using mobile devices. Not that they're going to be doing research on them, but it's still.
No. They will show things on the
phone to just
all times.
So let's do this. Instead of getting down into the nitty gritty of actual visuals yet, let's make an outline document that says, it spells out the pages that we want on our front-end website and what elements we want on there. So like we want some kind of graph showing complexity and function, and these are the key things on it. So we can start to have a checklist almost of when it comes time to implement. Okay, what's done, what's not done, and then of course we can just build out that outline with more details as they come to mind. That seems like a tractable way moving forward, right?
Yeah.
I mean, so let's get a Google Doc going, and the bullet point, basically an outline view of all the pages that we need and want and what we're going to have on there. And,
Yeah, sounds good.
And then, this will also be an overall view. We can start to highlight what's done, what's lacking. We can stick artwork on there. I think Ogon's got some good artwork out there. Seems to be the artist among the group. So that will be a lot of very useful work for when we get there, because we want, if we have that up front, it's going to make our implementation go for. I mean, even other things like what's our bloody color scheme that we want to use, what's our topography, and all that jazz. And we can steal a lot of that from using, like what Bootstrap does, but we'll probably want to customize it to kind of have our own style. So
it's gonna have badass looking.
So we should probably have a style guide as well, kind of document built out as well. So style guide, function outline view. Let's start with those.
Okay.
And let's get so just to recap here. Ogun, can you get, I guess, at least the initial set of rules, or I don't care who. I guess I just figure it'd be easier for you, from Igor. And do you want to tackle the implementation of the what do you call it, signal transduction matching stuff, or David, did you want to do that?
I'll take care of all this if Ogun doesn't mind.
What?
I can take care of all this if you don't mind. Can be my next priority once I finish the pipeline of the gene cluster. I can move totally to get this done. So I'll do the implementation, and I'll talk to Igor to get the things. I will run all the show in there.
I don't mind.
Okay, cool. Well then,
and once you guys are done, there's nothing else to do, and I'm still doing this, then you guys can come and help.
Come and rescue
but I
you.
think there's a chance that I'm gonna finish. So.
Great. All right. So Ogun, what do you want to tackle? I mean, what calls your name?
What are my options? Is it?
Well, there's building out the document that describes what function our website needs. There's.
Let me do that then. Let me think about it and make some notes about it.
Oh.
What is the second one?
Say what?
So this is my first option, and I'll take it.
Okay, great. So.
What was the second one?
So, and on that note, it'd be nice to have a collaborative, like, a Google Doc or something. I mean, you can do whatever you want, but it'd be cool for us to be able to, like, if we have an idea, just be able to jot it down on or make a comment on your doc or something.
Okay, let's do that.
Rise up. Rise up pads are awesome for collaborative work.
What'd you say?
Rise up pads.
Rise up pads. Is that like a website?
Yeah. Let me just send you one of these. Oh, it's super cool because, just rise, R-I-S-E, rise up, and then space pads. And then we're going to come, it's pad.riseup.net. That's what the ad is. Very good. So you can put a name or not. And then if you send me this link, send this link for us, and then I'll show you.
How's it different than Google Docs?
Yeah, but what would we use? How's this better than Google Docs?
You will see. Like, can you send me the link?
Okay. I will Slack you a link here.
Slack me the link.
On general.
First of all, it doesn't log anything that you do, but also you have different colors. See?
Okay,
Nice.
Google Docs have the same thing.
Yeah. But then also you can click on top of that and you can change your color on the right side, and then you can put your name.
Ah,
And also what you can do, for example, if you click on the timing, you see the little clock over there?
yeah.
And then you can press play, and then you see how this thing is actually progress.
Neat, neat.
And it's free and doesn't keep a log of what you're doing. So, because I'm all sorts of against this logging situation from Google, but yeah, you have to go back to make it editable.
Oh, there's a bad thing. It's deleted if no action is taken in 30 days.
Yeah, exactly. So this is for us to actually not, for us to get it done.
No, what if you don't do anything in 30 days and then you want to get what? I don't like it.
Okay.
Yeah. Yeah, I think I'd like to stick with the Google Docs on this. It's an interesting concept that you can just quickly go without having a Google account or anything. Yeah, I think we should stick with Google on this one. I'm with Ogun.
All right.
That's interesting. All right, so let's stick with Google. And cool. But thank you for sharing that.
So let me ask you a quick question. So we will have, so it's going to be single page application, right?
Yeah.
Okay. So we will have a page for each genome.
Maybe.
Maybe?
I suppose so. I hadn't thought through it. I guess I wasn't putting myself in that box yet. But maybe, probably, very likely, yes.
Okay. So we'll decide on which pages we'll need to visualize then. So it's not established yet.
Yeah, I mean, I guess this is. Yeah, we can do whatever, right? I don't know what the right choices are. I very presume, pretty much, presume there will be one per genome. I don't see why we wouldn't.
Okay.
So yeah, we'll say yes for now. And so I guess that's part of your thinking through is to figuring out all the pages
Okay.
and what their URL should be. That would be another useful thing. Yeah.
Okay, gotcha. All right, I got my answer.
Cool. And then am I right in that you're kind of an artist?
No, not really, actually. I'm not very good at that. I'm not an artist. I just like doing things, like creating things, but I'm not a good artist at all.
Okay. Well, if anybody has a kind of an opinion on colors or such,
Kristen made a very good school of colors in Negro's lab. Because of her, I learned a lot about aesthetics, and I think Ogun got some of this from my interactions too. Right, Ogun? We talk about colors a lot.
Yeah, I remember that.
So I think we all have more or less the aesthetics coming from Kristen, but I can actually share with you guys some tools for palette thinking. Palette picking.
Yeah, we should start playing around with those and settling on some colors.
There's some really, really interesting tools out there that I've been searching for a long time, actually. Big enthusiastic of color palettes.
Well, let's get them out.
In a way that it should be colorblind safe and so on.
All right, so Davi, let's add to your list starting a Google Doc for the style guide, and you can put a section on there that also involves some of the tooling out there and potential palettes we might want to talk about. Good. Awesome, and I'm going to try to get our infrastructure rock and rolling by next week. There's a good chance I will be gone next Friday, so I don't know if we can bump the meeting up a day. But if possible, that would be awesome. And Davi, I think we can jump into making your the module now. Are you taking Monday off or what?
No, I don't take offs.
My thing's
Sorry. All right, so let's. Depending on what happens with my week, I'm either off Monday or I'm off Friday. So that's why I guess I'll play that. Are you available Monday if I'm around, like 1:30?
I am. I'm good. Yeah.
Okay, so let's tentatively plan on Monday at 1:30, implementing your Gene Finder stuff as a module.
Sounds good.
Awesome. Well, I'm kind of talked out. Anybody got anything else, or are we
I'm
good?
done. Yeah.
All right.
All right. This was a very good meeting. We progressed.
Yeah, I think so too.
Very different aspects. It's very good.
Very cool. Yeah, I think we're made a lot of headway here. That's great. So good work on the FQL. I think this will be very exciting when we get it actually implemented. So
Yeah. Yeah. It will be very cool if we actually can manage to make something that flexible.
yeah.
It will be super cool.
All right, guys. Have a great weekend, and thanks again for all your hard work.
All right. Thanks,
See you.
Luke.
Bye.
Thanks, guys. See ya. Bye.